Hey, in this tutorial we're going to look at the compound angle formulas. So we've got a summary of our compound angle formulas here. So you find that sine of A plus B equals sine of A cos of B plus cos of A sine of B. This one you can't really muck up too much because it doesn't matter which order you put them in, you're going to end up with the same thing. So you just need to remember that it's sine of one times cos of the other plus the other way around. Okay? Our other one is cos of A plus B equals cos of A cos of B, take sine of A sine of B. The way I like to remember this is cos comes C comes before S in the alphabet, so it's our cos has to come before our sine. Okay, because remember this is going to be an issue if we put these around the other way because of our subtraction instead of our addition sign. Okay. Now in the textbook they go through a geometric proof for both of these, which I'll let you have a look at if you're interested in. Tan of A plus B is given as tan of A plus tan of B over 1 minus tan A tan B, and this can be proved using these two for tan of A and B. We also need to look at the case where our angles are subtracted. We have sine of A take B equals sine of A cos of B, take sine of A, cos of A sine of B. Okay, and cos of A take B is cos of A cos of B plus sine of A sine of B. Now, the only difference here is basically we can think of replacing our positive B with a negative B and thinking of how our negative angles work, and we end up with these two identities. This one we do need to be careful of, okay, but this one it doesn't really matter which order we put it in. Okay, there's not nice ways to think about it unless you come up with one yourself. Okay, but the thing is, all that actually happens is we switch these signs. Okay, we're switching these signs. And again, we can get our tan of A take B equaling tan of A take tan of B, and then that's divided by 1 plus tan of A tan of B. So again, we're just switching our signs here. Okay, so it's not too bad, but it is a bit of stuff to get your head around and remember. So again, there's some geometric proofs for this part in your book if you want to have a look. Otherwise these all just derive basically from these first ones. So we need to actually have a think about how we can use these. So we'll have a look at the case where we've got sine of 22 degrees cos of 38 degrees, okay, plus cos of 22 degrees sine of 38 degrees. Okay, and we need to think, okay, well, which one of our compound angle formulas is this, where we've got sine then cos, okay, plus cos then sine. So it's going to be our first case here. Okay, so we can say that is equal to sine of 22 plus 38. Okay, so we're going to be sine of 60 degrees. Okay, and we should all be comfortable now that sine of 60 degrees is equal to root 3 on 2. Okay, one of our identities, our exact values. Okay, the next web example we'll have a look at is where we've got to expand 2 cos of theta plus pi on 3. Okay, so we're going to look at using our cos of A plus B. Okay, so we're going to say that theta is equal to A and pi on 3 is equal to B. Then we get 2 cos of theta plus pi on 3 equally to outside of cos theta cos pi on 3 minus sine theta sine pi on 3. Okay, now we can evaluate some of those because we know that cos of pi on 3 we know that's equal to a half, and we know that sine of pi on 3 is equal to root 3 on 2. Okay, so we know those, so we can actually put those in. Okay, so we're going to come up here now. Say, well, we've got 2 cos of theta times a half. Take sine of theta times root 3 on 2. Okay, and we can simplify that because our 2's can cancel out with these 2 here. Okay, and so we get simply cos of theta times 1, which is cos of theta, take root 3 sine of theta. Okay. And that's our answer. Okay, so we've been able to simplify it down as much as we can. Okay, so our next one, okay, is we're going to look at simplifying simplify cos of 3 pi on 2 minus theta. Okay, so we need to think, okay, which one are we using? Okay, well, we're using cos of A take B. We need to remember that that's cos of A cos of B plus sine of A sine of B. Okay, so we need to say, well, we'll leave A equal 3 pi on 2, and we're saying that B is equal to theta. And all we're going to do is sub in the values that we've got. So we know, starting off with cos of 3 pi on 2 take theta, we're saying that's equal to cos of 3 pi on 2 cos of B plus sine of 3 pi on 2 sine of, I'll say that B shouldn't be B, that should be a theta, sine of theta, okay, because B is equal to theta. Okay, and we know some exact values. Okay, we know that cos of 3 pi on 2 is equal to 0, and that sine 3 pi on 2 equals -1. Okay, so since this part equals 0, this is going to drop out completely, and then so we're simply going to get cos of 3 pi on 2 minus theta is going to equal negative sine theta. Okay, because our cos of 3 pi on 2 is 0, so this whole term drops out. Sine of 3 pi on 2 is equal to -1, and -1 times sine theta just gives us negative sine theta. And that's all there is. Okay, so we'll look at the next worked example. Okay, not quite the last one, we've still got 2 to go. Okay, so we've got find the exact value of sine 13 pi on 12. Okay, so we want the exact value of sine of 13 pi on 12. Now, you can notice that we've got really sine of pi plus pi on 12. And it's that pi on 12 that's our issue. Okay, we don't like pi on 12, that stuffs us up. Okay, it causes us issues. Okay, usually we don't have our multiples of pi on 12 in our exact value table. Okay, so this is a way that we can deal with them. Now we're actually not going to split it like this. We're actually going to split it up a little bit differently. Okay, we're going to split it up as sine of 5 pi on 6 plus pi on 4. If you have a look, that's still equal to 13 pi on 12. Okay, So we're going to use that split. Okay, and then we go, okay, well, we've got two things added together in sine. So remember that sine of A plus B equals our sine of A cos of B plus our cos of A sine of B. Okay, so we've got to let our A equal our 5 pi on 6 and our B equal pi on 4. Okay, therefore our sine of 5 pi on 6 plus pi on 4 can equal sine of 5 pi on 6 cos of pi on 4 plus cos of 5 pi on 6 sine of pi on 4. Okay, now sine of 5 pi on 6 is equal to a half, and cos of pi on 4 is equal to root 2 on 2. Okay, we also know that cos of 5 pi on 6 is equal to negative root 3 on 2, and what have we got left? Sine of pi on 4 is equal to root 2 on 2. Now, for these ones here in particular, they come from our unit circle, okay, because this is going to be in our second quadrant, so we're really saying that that's pi minus 5 pi on 6, so a basic angle of pi on 6, which gives us a half for sine, and cos of pi on 6 is root 3 on 2, because we're in the second quadrant, cos is negative, so we're negative root 3 on 2. So now that we have this, we can put all our bits into our equation here. So we can say then that sine, I'm going to write as 13 pi on 12 now, okay, is really all of these things. So we've got sine of pi on 6 is half times cos of pi on 4 is root 2 on 2 plus cos of 5 pi on 6 is negative root 3 on 2 times our root 2 on 2, which is half, sorry, not half, it is root 2 on 4 minus root 6 on 4, which we can just write as 1 on 4 outside of root 2 take root 6, okay, to get our solution. Okay, so there's a little bit of work there, but basically we're splitting our fraction that we don't know, our 13 pi on 12, into two fractions that we can actually do, that we know we've got exact value for, or that we can find our answers for. So this might have seemed an odd way to do it. Okay, we couldn't have done it this way because the whole point was we were trying to find what our 13 pi on 12 is, and our pi on 12 is what causes our issues. So we need to find a different split for our fraction that we're using fractions that we could do. So we want bases of like 2, 3, 4, 6. Okay, so that's what we need to be looking for our denominators. Okay, so we've got one last example. Okay, and then we're done. So we're saying if cos of A equals 12 on 13 and sine of B equals 7 over 25, okay, where we have A is in our first quadrant and we have B is actually in our second quadrant. Okay, we want to find the exact value of sine of A minus B. Okay, so what we need to do is actually think about what we've got here. We need to think about our basic definition of cos. and it's our adjacent over our hypotenuse. So we can think of a triangle here. Our right angle triangle, that's our angle A here, and we've got our adjacent of 12 and our hypotenuse of 13. Okay, so we can work out our other angle, okay, by a bit of Pythagoras. So we say that we've got square root of 13 squared take 12 squared, okay, which is equal to the square root of 25, which is equal to 5. And you'll see, I accidentally mucked up there, our 12 was our adjacent. Should have been there, sorry about that. And our 5 is our opposite. Okay, so we've got our nice little right angle triangle there. Okay, so we know then that sine of A equals our opposite over our hypotenuse, so it's 5 on 13. Okay, so we do a similar thing with this one, this triangle here. Okay, so we go, okay, we've got to do a similar thing. So we've got to go, okay, set up our right angle triangle again. Okay, but you'll see, I'm going to set up this way. Okay, and you'll see why in a second. Okay, so we have sine of B, so B is our opposite. So B is no opposite, 7 is our opposite, and 25 is our hypotenuse. So again, bit of trig gives us our other side. Okay, and we go then that we've got 7 squared plus 25 squared, that is wrong. So square root of 25 squared take 7 squared. Okay, and that's going to give us square root of 576, which is equal to 24. So our other side is 24. Okay, and that means that we can say, well, we had our angle B, okay, which we'll get to in a second, okay, that we talk about then, well, it's got to be our adjacent over our hypotenuse, which is 24 over 25. Okay, but B, okay, is actually here in our second quadrant. Okay, so the idea there is really that our B is actually the angle there instead. Okay, and all that means is that because we're in the second quadrant, that has to be a negative value there. Okay, that has to be a negative value. So we're getting there. So you need to go, well, sine of A minus B. Oops. Sine of A minus B. Well, remember that is equal to sine of A cos of B minus cos of A sine of B. Okay, so put in all our values. Okay, so sine of A we found was 5 over 13. Cos of B we found was negative 24 over 25. We know cos of A, we're given that, that's our 12 over 13. And sine of B, we're given that, is 7 over 25. And so we find when we do that and we simplify our fraction, okay, we end up with negative, it's not a nice number, 204 over 325. Okay, so we start off with our nice, well, I won't say necessarily nice, but we start off with all of our double angle formulas. Okay, here. Okay, and basically we've gone through different situations where we've either used those or manipulated those to either prove things or solve different types of questions or equations. So hopefully that's enough to get you going on those questions, from that exercise.